All right. So we are back here again to do some more work on my research. I did some thinking, and I'll get to some of the things I realized earlier in a moment. Let me get some music going. All right, that should go. Do well. All right. So last time I was extremely confused about basically what was going on with this average accuracy not being an array. Originally it was like this. Despite the fact that down here when I actually log my metrics that it's very clearly an array. The answer turns out to be relatively annoying. One moment. Alright, so the answer effectively is that this for loop right here didn't used to exist. I added this for a reason I do not remember, to make it so that I was pulling each item out individually by a label rather than using vectorized functions. So this for loop and these two statements didn't used to exist. And all of this used to be vectorized. So this was a whole array of labels, and then you'd have your whole array of outputs, and it would create an array of precision. And same thing with accuracy. Unfortunately, average precision would require a summation in order to be applied to a single number, but still that's how it would work. So what I need to do now is decide if I keep this, like what was the purpose of this? I mean, it very clearly allows me to do a literal per item per label classification. We theoretically are using a batch here, right? If we assume we're using a batch with the data loader. Yeah, all of this would work with vectorized operations. Same here, these are all vectorized. And all this is vectorized. So really it's like numpy rounded out is just it's really, so the shape of numpy rounded out here would be batch by probably label size. Oh. Oh! It all makes sense now. If this is the shape, and we're just for looping through the first dimension, we're not for looping through the labels, we're for looping through the batch. So R out, the shape of R out is now just label count. Because we're processing it on a per batch basis. It's not one item, that's the change I made. I made it to support batching. To make, that explains why it actually worked when I ran it last. Okay. Okay, yeah, that makes a lot of sense. The precision still works the same, unfortunately. Frankly, I could probably do this precision score with... this probably works with batching. I probably don't need to separate this out. All three of these probably work with batching. The only thing that wouldn't work with batching... Well... All of this should work with batching. Why did I do it on a... Why did I for loop this thinking I had to do it individually? Alright, this is what I'm gonna do. One of the things I thought about as well is I believe in my testing I created a smaller dataset, kind of a test dataset. Like a mini dataset. Where are you? Data OG. This is it right here, actually. Yeah, 1228. Which one am I pulling? Okay, I'm pulling whatever's in my data folder, so that's exactly what I thought. Models, data. Yeah, those are not. So theoretically, I could switch this to my mini data set. Go ahead and do that. I'm struggling. Should be in here. Yeah, there we go. We'll switch this to my mini data set. Do I? Hold on, I'm confused. These aren't CSVs, these are PT files. Which would be in here. No, they're generated from here. Into here. The preprocessor probably generates those PT files. It would be really nice if I had the smaller versions sitting somewhere so I could test off of them. Alright, I'm gonna do something risky. We'll see what happens. I am going to run the model. I saw what happened last time. It basically killed my stream. but I was using GPU. So what happens if I use CPU for inference? Theoretically, it'll be slower, but it may not destroy my... It may not destroy my stream, so that's the important part. Let's give it a shot. If I can find out where I set CUDA. Probably when I initialize the model. Right here. Yeah. That's exactly what happens. So if I do this, let's see if I destroy everything. I mean, this probably still isn't logical, given how much data I have to go through. But just to see the effect it has on the stream, I'm gonna go ahead and get it started. See what happens. I'll kill it immediately if it becomes a problem. Until then, I need to figure out how to get the smaller data set. I might actually have to generate it, which shouldn't take long. Alright, model is inferencing. Stream seems to be happy. Let's see if I can get even one item. The other thing I thought about today was that the main changes I wanted to do, log loss was one of them, but really what I wanted was to make this faster. I wanted to use more GPU cores at the same time. Now my computer doesn't have that, but the workstation at my school's lab does. So if I can greedily use as many GPUs as possible, I might be able to speed up the inferencing. All right, well, I think bright side, I mean, we can see right here that this is not affecting the stream. So even though it's inferencing and it's going to take forever, the stream is still working. So I'll go ahead and kill the inference because I don't care. We really need the smaller data set, which probably means I have to open it. Transformer preprocessor is exactly what I want. Where do you get your data path from? Probably the metadata, right? Like, so theoretically I could just hit this and have it gen. Yeah, this should be quick. Right. See what my task manager is doing right now. With everything that I'm doing, my CPU is still only at 63%. So yeah, we're good. CPU is happy. And should not theoretically be affecting the speed of my computer or my preprocessor. So then the real question is the preprocessor preprocessing the right data? Which I believe just comes out of this metadata file. Man. Oh wish Notepad++ was right there. Yeah, this is a short metadata file. This should work just fine. Also, lay down, please. Thank you. Oh, I knew this would happen. This dataset is rather large. And it's not even that many files. This is the small set. I vaguely remember it going faster than this. One of the things I can do once it's finished to make it even faster, I can short circuit the training so that it only does one label. Where is it? I remember doing this before. Although, now that I think about it, Oh, it's here, right? So this is the per label training. No, that just grabs the X and the label. So that grabs the batch and label array. It doesn't even care, does it? Alright, what I can do then is I could just hit a break here or a return. After a single optimized step, I can just throw a return in there and that would short circuit it. In fact, I could probably do that right now. Oh no. We're gonna return. Well, let me note this. There. So that'll short circuit that, and then we'll go into the test label, and that should allow us to actually see some of the shapes here that we're talking about. Oh. What are you doing? Oh, the preprocessor finished. Not that I don't think I need it anymore now that I came up with these ideas. Okay, where did the preprocessor save the files? And do not tell me it saved it down here, because if it saved it down here, I'm in trouble. No. I'll have to look it up. Regardless, it's not important. We'll just use the full-size data files now that I'm short-circuiting it. Darn kids, they won't lay down. Alright, yeah, so we want to stop there. We're running off CPU, so it shouldn't kill the stream this time. I do, however... I want to walk through this. Yeah, it's the train loop. Okay, so let's walk through this. It should go super slowly right here. But we're only processing one batch. Which I think batch size on my computer is literally just one. It might be two. Yeah, batch is just one on my computer. So it's literally one, I say image, it's not image, one spectral set. Oh, I'm lagging. Oh, I'm lagging hard. Oh boy, I'm lagging. Wow. Alright, well, I don't know what that did to the stream, but I'm still here. It's fine. It did exactly what I needed it to do, which was its job. What I might do in future development streams is record off of my Thunderhead server. That way we don't have to worry about this kind of stuff. Alright, then we return, go into our test loop. I can actually hit continue here and it should stop. Unfortunately, it's going to inference again, so we're about to freeze. Where's my console? Alright, this is exactly what I wanted. So rounded out is exactly what I thought. It's an array. But it's not an array. Yeah, it's an array of labels. Wait. NP rounded out. Yeah, okay, 1, 9. Right? And so shape 0 is going to be 1. So R out's going to be still be an array. Yeah, okay, yeah, I was right. This for loop just supports batching. Now, unfortunately, my precision, which we've already proved is still mathematically accurate, is literally just an array. Interesting. This is not a per label array. This is a per input precision. So if I wanted to make this per label precision, that's going to be a lot harder. There's accuracy, I mean, that's just per label. Alright, so if I wanted per label precision, what I would end up having to do is implement the equation in a vectorized fashion, which actually wouldn't be hard. I think I'm going to leave that out for now. I don't want to waste time getting a metric that I don't actually need right now. And instead, I'm going to focus on, speaking of which, log loss. I implemented that last night. Neato. That's good to check on. the cross entropy loss returned a tensor for every label. So that's loss for every label. That's not the combined average log loss. So I need to actually average this, which isn't, that's not hard. I thought there was an average function. Maybe that's like, ooh, I bet it's built into tensors. Alright, well. That's gonna be a problem, because that's a tensor now. Which means every operation after that's gonna be a vectorized operation. Do we change this to CPU? We do change it to CPU down here. Alright, what I'm probably gonna have to do is this. I'm gonna have to squeeze it twice, not just once, and force it to CPU. Log loss at squeeze 0. See, here's the kicker. This is probably batched too. I can probably squeeze the center. Yeah, so I can squeeze the center, but then I have to deal with the batch value. But if I could just average the tensor as a whole. All right, let me check that. Torch.mean. Alright. I thought there might be a way. We can torch.mean this. That'll take care of everything. That being said, how is count calculated? Because the count I'm using now with torch.mean is effectively this count, which is the number of batches within the data loader or the data set. That's not right. Count, where are you? Okay, yeah, the count is the actual count. Although that... Except the batches aren't guaranteed to be even, the last batch might not be even. So to get the real value here of the average log loss, what I really should do is let it be a tensor. That just... Alright, this is what I should do. I should treat it the same way I'm treating the average, basically. So we're going to squeeze the middle term, attach CPU, and that'll transform that into a 2D batch by label count, which is exactly what everything else here is. And yeah, from there I can just vectorize that'll create a combined per label loss. Yeah, per label loss on a per item basis because we remove batch. And then I do this. That creates a per label average. This is a per label average of the log loss. Oh, it's just already there. And then the last step is to mean this. I can mean the per label average, combining the labels into a single value. Yeah, that's the right math. And that fixes my log loss problem. I just initialized NP log loss. Where did it go? It's not compiled. That's where. So I do have to run this again. That stinks. Don't need to walk it through though. We know it'll work. Alright, well that's going. torch.utils.data.distributed. Spawn a process per GPU, basically. Right, I was gonna check to make sure NP log loss existed, which it does. In exactly the shape I wanted it to. Oh, I broke something. What didn't it like? It didn't like my plus equals. It's not the same shape. And shape is gonna be the death of me. I know what I did wrong. Trying to figure out this example so I can understand it a little bit better. I don't know what rank and world size means. I suppose it probably would explain it down here somewhere. Or there's PyTorch Lightning. What's this about? Alright, I'm not really interested in remaking my classes. I was just hoping there would be an easy way to distribute. I'm not... No. Okay, let's not do that. All right, yeah. So that's what I'd want, basically. So that creates a per label numpy array, which in the end would come out here. I'm scared to run the inference on so many items. I'm not gonna get all the way down here. I'm just gonna have to assume it works. But I mean, I'm basically doing that exact same thing on accuracy. Right, you've got your per label accuracy and then you mean it. You have to divide it by count first to get the, yeah. It basically mimics accuracy, so yeah. And we know accuracy is right. So I'm gonna call it for the log loss setup, and we will keep going with trying to distribute this data training. Leading Phase Accelerate is designed for users who want the power of multi-GPU and mixed precision training without giving up the flexibility of standard PyTorch. The 5 lines of code integration. Initiate the accelerator. I'm not sure how I like that. It was all going great till I got to, you don't run it with python train.py. You run it with accelerate config. Which means I would have to, in my Docker container, initialize or I'd have to install accelerate. And then change my scripts. Like, I suppose I could do that. Like, that's possible. This might be the route I go. It's probably the simplest to implement. And the only gotcha is the fact that I'd have to make sure Accelerate is installed in my Docker container. The other thing is, can I run it from PyTorch? Or not from PyTorch, from PyCharm. That should already be handled. Let's go back to here. Make sure I understand this correctly. You create an accelerator object, and instead of setting the device to CPU or CUDA, which is what I do on the initialization, right? Your optimizer, that's not a big deal. Your data loader, that's also not a big deal. And then just change your backwards. I'm assuming that works in my object-oriented structure. I mean, it would be just as simple as to say I'm assuming model.2 works. This feels very Inception-y. I don't think my base model has a device. It does not. So that might be something I have to look at. Yeah, I'll probably do that. Tired. Speaking of... I need to work myself up to actually start making these changes now, because what if it doesn't work? What if I regret life by doing this? I'm misspelling that horribly. Dude, what the frick? We'll go ahead and install this. I don't know how I'm going to square this with my device property. It may be better to do this, which is to initialize the model, then model.to. So then we do something like model.device. And then model equals model.to. That feels wrong. Feels wrong to type it that way. There we go to the model. Optimizer and data loader. See, it does everything outside the model class. Model, optimizer, and data loader are all outside of that. Here I have my data loader inside the model class. I mean, theoretically, I could pull this out and change these values. But I like enforcing the class that you have to use for your data structure. your training loop is a method inside your model class, you can still use it, but you need to be careful where you initialize accelerator and how you handle the prepared objects. The most important thing is that accelerator.prepare wraps your object in new classes. If you call it inside a class method, you need to update your internal references. So if we do accelerate.prepare, I see, we could call it on self. But that gets a whole separate model. And then we'd have to use the model object during training. I see what it's doing. Again, that feels really ugly. It all comes down to this. The model you use to inference is not self. It's a different object. Which is something I can actually live with. I can live with that. So that makes it a little easier too. Because I don't have to change anything in here. Not only that, but it doesn't affect any of my other model implementations. The fact that I'm using accelerate is literally a feature of the model now. So I need to know my data loader, which is right here. That's fine. And we really only want to do this in our train loop, not our test loop. So we have our data loader, we have our optimizer, and we have our model. So we're really just cruising at this point. So from here, I don't care about the accelerator being a property. Maybe I should. Yeah, maybe I should. Alright, fine. You have convinced me. That way, the device is consistent. So I can do this. I can do... we'll get through the stuff first. Dude, come on. Wow, it does not want to copy paste off of Gemini. Either that or my keyboard's lost all power. It's fine, we'll steal this over here. And then pretty easy to do this if the device is torch. Not torch, it's accelerate. And really I set all the devices up here, so like I'm going to I don't think I've ever used model.2 before. Wait biases and buffers from one hardware device to another, most commonly CPU, GPU. If I do this, I don't need to. Alright, so that's what we'll do. I'm going... and that makes life easier. So after all... Fix shapes to actuals. Aren't they already actual? This is irrelevant. So after I define the layers, I can do self.to self.device. You don't need to state the device for layers. They'll still need to be careful with tensors, which is fine. I think I already do that, so that's... And I'll run a quick test on this. Ooh, I forgot to ask, I forgot to check to see, make sure I can run accelerate and PyCharm. Alright, that's what I'll have to do. I'll have to make a note of that. Okay, so we define the device, we set the model to the device, carrying the constructor, which is all good. Go to our train loop, we have our loader, optimizer, and model. So from there, we should just be able to do what we talked about up here, which is the dot prepare statement. And I do like prepending this with prep model for clarity. Why does it not like that? What are you talking about? Expecting a list. It wants a list? Accelerator.prepare model optimizer data loader. I was doing that, so why? I don't understand why it's complaining. That matches both documentation and Gemini. Anyways, those are the twos, which is fine. Here. And we do prepped model. And then we do the accelerate dot backwards. That should theoretically be everything we need to do to make this work. I might have to move my optimizer up. I think, yeah, the optimizer should be done per epoch. Or it shouldn't be done per epoch. Okay, so that's a mistake I was doing. Let's go ahead and move this outside of the loop here. Throw it in here. That allows us to only prep once, which is what it said we should be doing. Now that does mean I'm gonna have to pass, either I have to pass in the optimizer or I have to pass in the prepped model. Alright, so this will ensure it's only ever created once for the lifetime of the model. Got awfully quiet. Is my music over? Yes, it is. So if the optimizer is none, I might just want to prep these separately, actually. Because I'm going to have to... Well, actually, I have an idea here. If the model is not prepped, then we need to prep everything. If the model is prepped, then we can assume only the train data loader needs to be prepped. There. That works. Oh, is none. I forget. Freaking PyTorch. Not PyTorch. Python. My goodness. Initialize our accelerator during constructor. Set the device. We call our train loop. We prep model, optimizer, and train data loader. Then we need to pass them all in. No, we don't, because these are properties. So we can assume all of this. And then we don't want to use the accelerator for the train dataset, or for the test dataset. I don't think it's as critical. Generally speaking, it's a smaller set. And if that's wrong, no, that's right. It's an inference. The test loop is a complete inference, so I don't need to worry about that at all. Although this concerns me, I'm just going to leave it for now. Don't use the optimizer. And I don't really care about the data loader. I could be wrong. All right, let's ask the Gemini expert, I suppose. Well, if you need to save the model or use it in a completely different environment, I need to unwrap it first. Oh, gross. I do not, oh my goodness, I do not save checkpoints. That's the other thing I need to change. I need to save the model. I need to save the model as checkpoints. And yeah, I should torch dots. I need to do this. Oh, brother. But this is probably wrong. It should probably be prepared model.eval. I hope I'm right in that thought process. Alright, but I'll need to prepare my test dataset too. Oh. Hold on. Kids are screaming at me. Alright, I will leave you guys with some ambience. I need to go tuck my kids into bed. Actually, who am I kidding? They're probably going to scream and cry and want me to sit up there for a while. Not scream and cry. They're not really going to scream and cry, but they liked to me be near. So I'll call it the end of the stream. Thanks for hanging out with me while I go through coding. I may or may not be back tonight. Just assume I'm not going to be back tonight, and then if you get a notification, great. You can come join me. Anyways, kids are yelling at me. I gotta go. Thanks for your time, and I hope you guys have a great night.